Okay, so this is question 4. I told you during the last video that I will create a video for question 4. So this question is when a fluid body, so you say this fluid body is accelerating linearly in a vertical plane with a constant acceleration which is ax, and this acceleration it is in the horizontal directions, and az it is in the vertical directions. Pressure Pxz at a location with coordinates x, this is the horizontal distance and the z is the height, in an xz coordinate system with origin O. So which is given Pxz, this is equal P naught, and this term and this term. You can say this is actually the term for x, and this is actually the term for z-axis. So in this system we have the horizontal and the vertical axis x and z. So definitely this is the pressure at the origin. That means we can say this is actually the 0, 0 positions, the pressure at 0, 0 position. So if you go into the theories, then you say we will always assume that this pressure is 0. Maybe we'll say a point, a position where the pressure will be 0, 0. So that's really important. For most of the question it will be given, and here P naught is the pressure at the origin. So J, this is the gravity constant. A actually it is the accelerations, and the another important thing is the slope of the plane of constant pressure, which is given dx over dz equal this, which is negative ax plus az plus j. Look, the dimensions are 3 meter long. The rectangular container, it has a rectangular container 10 meter long, 1 meter high, and 1.2 meter wide. It is completely filled with water, and the container's top is completely open. So the top of the container, this is open. It is accelerating horizontally in the direction of its length at a uniform acceleration, which is 10 meter per second. So you see that ax it is acting in the horizontal directions. So this is 10 meter per second square. Yeah, definitely. That's when it is acceleration. The unit is meter per second square. We need to determine we need to determine the amount of water which is filled, and the total force by the water on the container's back wall and the bottom wall. So let's say this figure here. So this is actually the rectangular container. Look at this axis. This is actually the x-axis. This is actually the z-axis. So it is given in the question: x is the horizontal and z is the vertical axis. A, B, C, D, E. This is a rectangular container. The top surface, it is completely open, right? Yeah. Gravity is always acting this way, and in this question most of the informations are given. The container, it is 3 meter long. That means from here to, actually it should be here. So it is 3.3 meter. The height, it is 1 meter. The height AB, this is 1 meter. It is 1.2 meter wide. So it can accelerate into this horizontal axis. You can say maybe some point, acceleration point, it can accelerate like this way in these directions. Now this is the free surface, this is the slope, and an expression is given for this slope. If you see here, the slope of the plane of constant pressure is dz dx over a negative az over az plus g. So this is given. This is actually the slope. So it creates an angle theta here. See, if we say this is an angle theta, so maybe we can draw a line like this. This is the horizontal axis, this is the vertical axis. So if it is theta, it will create also another angle theta. If you can remember, I said at the beginning the pressure P naught, this P naught, it is actually the pressure at the origin. So for every question, this is really important. We need to set the origin. So let's say this is actually the origin A. This is actually the origin point. So when it is origin, this is 0, 0 point, right? So that means 0, 0 means if you have some understanding regarding the plot. So if it is x, if it is y, if we say this is 0, 0 point, so origin, that means it is 0, it is 0. Let's say this is x-axis, this is z-axis. That means at this point, if we say this is A, so at this point, the x position, x equal, it is 0, and z equal, this is also 0. So this 0, 0 means x equal 0 and this z equal 0, right? So that's actually the coordinate system. So if this is a origin point, so that means this 0, 0 means x, it will be 0, z, it will be 0 here. And now look at this distance, 1 meter. So the x-axis, this is the directions. If we consider the position, the point B, what will be the coordinates for B? You see, at this point, can you see from this A to B, this is a vertical line. So if we consider this point A, this point B, what do you think? This is x-axis. So is it changing for this x distance? You see, this is the same positions. So actually x here, it will be 0. What is the z? So this is actually the z-axis. This is the z-axis. So where, if it is 0, 0, so this is 1 meter. So we're going to the opposite directions. So we can say this is -1. So that means here x equal 0 and z equal -1. This is the coordinate points for B. Why I'm writing here? We actually need it later. So I believe that you understand this. Like B, the coordinates at B, it will be 0 and -1. Because 0 means x equals 0 here. This is the same point along this x-axis. If I draw some imaginary line like this way, so consider this axis and this axis, this is same. So x, that means 0. And for the y, sorry, not y, the z, it is coming to the opposite directions. So this is the positive direction. So if we come to this way, so it will be -1. This is actually the coordinates. Okay, so let me delete this one. So now we'll start solving this problem. If you can remember here, we have the slope, the expression for the slope, dz over dx. Dz means the differential term for along the z-axis, and x means along the x-axis. So let's see how to solve this section. So the slope of the free surface, which is given dz dx equal -az, ax over az plus g. So all of you can remember the acceleration ax along the horizontal axis is given 10, and the acceleration along the z-axis, it is actually 0. This is the z-axis. So if it is the 0, 0 point, origin point, the slope is coming this way. So it is changing along the x-axis, not along the z-axis. So az, this is actually the acceleration along the z-axis. So it will be 0 here. And we know the gravity term, this is 9.81. So if we simplify this, we'll get this value. It is 1.02. So that means dz over dx. So we can write it as -1.02 over 1. So -1.02 means if you divide by 1, so that's the same thing, it is 1.02. Why I wrote this way? So that means dz it is equal negative 1.2. If it is equal, if I say dz over dx equal negative 1.2 over 1, so we can say that this dz this is equal 1.02 and dx equal 1. If you see the drawing here, you see that we wrote it dz equal negative 1.2, dx equal 1. You see how it actually comes. So we got the differential values for along the dz and the dx axis. So now this is actually the rate of change, the slope. Now we need to calculate the angle theta. We can see that it creates an angle here theta. So we know how to calculate theta. So actually, if you see this side note here, we know tan theta I explained when I solved some other problem, and if you see the previous video for G3, then we explained how we actually come tan theta, how to calculate this tan theta. So this is actually the vertical force along the horizontal force, something like that. Actually, when it creates an angle, then you need to see the corresponding edges. So anyways, so in this case, actually, if I say this is the vertical term, okay, and this is the horizontal term, so we got it is negative 1.2, which is dx equal negative 1.2. This negative value, this is actually telling you the directions. Okay, so this negative value, this is actually the direction. So when we will calculate the angle, we don't need to consider that negative, so you can just assume the positive value. So if dz dx equal on negative 1.2, so we said it should be positive because it is actually negative, but negative is the direction, so we don't need to consider that. So if I say that this tan theta, this is equal 1.02, so that means theta will be here, see, tan inverse 1.02, and if you use your calculator, then it will be 45.6 degree. So we got the angle. So now for this geometry here, you see that we have a triangle ABC. So for this triangle, we know the value of AB, we know this angle theta, which is 45.6 degree, but we don't know the BC. So let's calculate BC, because actually we need to calculate how much water is spilled and actually the force on this wall, and it's actually the force on this wall as well. So we need to calculate that. So if we want to calculate the BC, so it's creating an angle theta. So you can remember for this area ABC, tan theta equal AB, this vertical is over this BC, this base BC. So we know AB equal 1. So let's say AB equal 1 here. So it will be tan theta equal 1 over BC, and we know theta equal 45.6 degrees. So you can write it as tan 45.6. Okay, so tan 45.6. So then BC, actually, tan 45.6, this is actually 1.02. You see that we got it from here actually. So you can either put theta equal 45.6, that's alright, whatever it's up to you. So you can put it as this theta value 45.6 here, or you can simply put 1.02, that's it. So now we will get the value 0.980. so that means for this BC equal, it is 0.980. we need to calculate how much water, actually our target is we need to calculate the spilled water, the amount of spilled water. So let's calculate how much water left in that area ABC. So it is actually a triangle. So the volume of the water left in that ABC section, so it is, if we can calculate by using, if it is volume, that means it is area into the void. So area equal for triangle, half into the multiplication of these two edges. So this is vertical and the horizontal. So it is AB and BC. So we can write it as half into AB and BC, and the weight it is I can remember it is given 1.2 meter. So this is half. AB equal 1 and BC we just calculated 0.980. So put this value, it is 0.588. Okay, so this is 0.588. We got this value. So this is the volume of water left. But what is the initial volume given for this rectangular domain A, B, D, E? For this rectangular domain, if you see here, the initial volume is, for the rectangle, you need to multiply the length. The length is 3, the height, and the width. So it is 3.6 meter cube. And it is 0.588 meter cube. So that means it was the initial volume, and this amount of water is still left on that surface. So that means the volume of water is spilled is 3.6 minus this. That means 3.12 meter cube. That's the first part we solved. So we have done with the first part, right? Now the second part. This is really important. You need to understand this section. We need to calculate, the force on this all AB and this BD or BC. So we know the formula. If you can remember, there is the formula is given the pressure at any point, xz point. It is the initial pressure at the origin and along the x-axis and the z-axis. So if you see the side notes here, the pressure at a point in the fluid body, so you can see this space 73. So pressure of Pz xz along this at this point, and which is relative to A. That means A is our origin. So for that theories, according to that theory, it is PA. So this is actually the origin, and the density rho, the AX is the accelerations, and X relative to A. This is actually the position, the X distance, and negative rho AZ plus G. This is Z relative to A. So this is actually the formula, that we used. It is given in the question, and if you see it base 373 of your book, then you will get all the derivatives there. So I said at the very beginning, the pressure at origin at 0 point, definitely it should be 0. So this is very clear. At 0 point, pressure will be 0. So you can say that P of A, it is equal 0. And now see here, if you can remember, I said at the very beginning the coordinates of B relative to A. So we wrote here xb equal 0, zb equal -1. Let's see here, if you can remember this section. I told you this is B point is 0 and -1. So that means this is x, this is z. So xb equal 0 and zb, this is equal -1. So you see here xb equal 0 and zb equal -1. Now if we calculate the pressure at these positions, look here, if we want to calculate the pressure here, PB, okay, so the formula, it is the same thing. So we say this is PB, so it will be origin PA, it should be same, rho x and x relative to A. So this is XB, okay, because we are calculating at these positions. Similarly, this is rho AZ plus G, this is ZB, okay, this is ZB, which is relative to A. So we are calculating with respect to A. A is the origin. See, PA, this is equal 0. Density is 1000, order density. AX, you can remember this is 10. What is XB? 0. So say this is 0 here. This is again 1000. AZ, you can remember AZ equal 0. No accelerations along Z axis. G equal 9.81. What is ZB? ZB is equal -1. So this is 981 Pascal. So we get the pressure at these positions, at this position B. we know the pressure at this position A equal 0. So if we want to calculate the force on this surface, this wall, force equal pressure into area. So the first part, if you see the question here, we need to determine the total force by water on the container's back wall and the bottom wall. So here actually the back wall is AB and the bottom wall is this. So now we will calculate, so we got the pressure at this position B, PB, we know PA, so we will calculate the force on the wall AB. So it's because pressure varies linearly with respect to x and z, so we have only x and z axis, and we got the slope. So it's then the total force on the back wall AB, the force AB equal the average pressure on AB into the area of AB. So what will be the average pressure? Average pressure, it will be the pressure at this position A plus pressure at this position B over 2. So that should be the average. So we say we calculated the pressure P, average pressure PA plus PB over 2, and if we just this simple calculation, so it will be 4905 Pascal. So we have the pressure. So we know the pressure and what is the area of AB. So we can simply calculate the area on AB, then we will get the force on the wall AB. So look here, the force equal 4905 into the area of AB. It is 1 into 1.2. So 1 means this is the height and the 1.2 is the weight. You see, I believe you can remember this is 1 meter and the weight it is given, you see 1.2 meter. So that means we got the force on the back wall AB. Now we will calculate the other. So now similarly we can calculate the pressure at position C and position D. So C at this position C, at this position D, you can see it is 0 pressure. This is the slope actually this area ABCD. This is out of this domain. It is along this x-axis. So as it is out of this domain, the pressure, there will be actually no pressure, nothing is happening at these positions B and D. So if the pressure at this and point C and this point D, if it is 0, then there will be no force as well. So the force on CD surface, this is 0. But we will have the force on this surface, this wall BC. So for the force on BC, it will be the average pressure on BC plus the area of BC. This is actually the area. This is actually the area. So for BC, the average pressure, it is PB plus BC over 2. So we calculated PB. We know BC equals 0. So it will be 4905, the same. And now let's calculate the area. So this is the area. Okay. So now we got the total force on the surface BC. This is equal 5768 Newton. So that means the total force on the bottom of the tank, it is this force FBC plus FCD. So you see it is 5768 plus 0. So this is the force. So that's actually the answer. So that means we have done with this problem. So what we did initially, if I just do a quick review, we just used the slope expression and then we got this value dz over dx, and then we calculated this point B, right? We calculated the distance BC, we calculated the angle theta because we need the force on this surface. So we calculated the pressure at this point B. So then I calculated the average pressure and then I calculated the force for AB. Then we calculated pressure for C and D. This is actually 0. So the force on CD surface, it will be 0. And now we calculated the force on this BC surface. And then I just calculated the total force on the bottom wall. So that's it.